y ahora sí llegó el momento de irnos al futuro. ¿Recuerdan cómo arrancó este 7º Digital Finance Forum allá por las 9 de la mañana? ¿Recuerdan en qué año estábamos y cómo era la tecnología, lo que podíamos hacer? Hoy nos vamos a ir al 2050, con el hombre que hace más de 30 años pudo contarnos, antes que nadie, cómo iba a ser este 2025, cómo iba a ser nuestro presente con un detalle quirúrgico. Él es físico teórico, es divulgador científico y muchísimo más. Tenemos el privilegio y la alegría de presentar a Michio Kaku en la Argentina. Bienvenido, un fuerte aplauso.
Thank you. After such a great introduction, I can't wait to hear the speaker myself. Let me say that I do a lot of television and radio, and I get a chance to interview great scientists. Whenever I interview a great scientist, I ask them the key question, the most important question of all. Is there intelligent life on the earth? Well, I was watching the Kardashians on TV last night, and I've come to the conclusion that nope, no way, no intelligent life on this planet, except in this room. I think in this room, we have some of the most thoughtful, intelligent people. So congratulations. You are among the smartest people on the planet Earth. Let me say that in my books, I've tried to convey the excitement, the vigor, the energy that goes into new discoveries, unlocking the secret of the mind, unlocking the secrets of the universe itself. In my book, when I talk about the God equation, I talk about what I do for a living. I work in something called string theory. What is an electron anyway? We used to think that an electron was a dot, a point particle. Nope. We think that it's actually a string, a vibrating string. And when you twang it, it vibrates in this direction or this direction. So an electron can become a neutrino. It can become a quark. It can become hundreds of different subatomic particles. In fact, we think all the subatomic particles of nature, thousands of subatomic particles, are nothing but musical notes on a tiny vibrating string. This would be an electron. This would be a meson. This would be a quark. And so what is physics? Physics is the laws of harmony of vibrating strings. What is chemistry? Chemistry is the interaction of vibrating strings. What is the universe? The universe is all the vibrations of the universe itself. And then what is the mind of God? The mind of God, according to this picture, is cosmic music, music resonating throughout the universe. And that's my book, The God Equation. And then in my other book, The Future of the Mind, I talk about how we physicists are now probing the inside of the mind itself. We can now see thoughts as they're being developed inside the living brain. We can actually see pictures. In my book, I explain how pictures can be extracted directly out of the human mind. This is incredible. Think about it. Your thoughts can now be taken by an MRI machine. And it also answers many mysteries. When I interviewed these scientists told me that it was a mystery that when you put a man in an MRI machine and you show him a picture of a pretty girl, he starts to act stupid. So why is it that a man, when he talks to a pretty girl, starts to act stupid? Well, in a brain scan, we can actually see it. What happens is blood drains from the prefrontal cortex, and the man starts to act stupid. So we now know why is it that people act stupid. We now understand. So in these books, I talk about the future of artificial intelligence, the future of space travel, the future of aviation, all of it in my books that I've published here. And my latest book talks about the future of what's going to happen on your desk. On your desk, you have a laptop. You have a computer. That computer is digital. In the future, where will you find digital technology like in your laptop, in your cell phone? And the answer is a museum. All digital computers of today will eventually become obsolete because we're now entering the next era of computation, quantum computing. And I'll talk about that in my talk. We're going to be computing not on silicon, not on transistors. We're going to be computing on atoms. This is the ultimate computer. And there's a race between the Chinese, the Americans, the Europeans, to perfect the first quantum usable computer. This is the future of computation. But in order to understand the future, which is the subject of my talk today, you have to understand the past. Throughout most of human history, we lived in misery, poverty, disease. Think about it. The average lifespan for most humans throughout human history was less than 30 years of age. We were born, we had kids, and then we died. We didn't live very long for most of human history. And what was it like to live like this? What was high-speed travel? High-speed travel was getting stuck in the mud with your wagon. What was long-distance communication in the past? Yelling out the window. That's life for most of human history. But then something happened. Something magical happened. And that is, we physicists begin to harness the power of energy and the atom, starting with steam power. With steam power, all of a sudden, with boiling water, we physicists could calculate how many ergs of energy to create a dynamo. And with a dynamo, we can create manufacturing, the Industrial Revolution, locomotives, power beyond human imagination. All from the mind of physicists, unlocking the secrets of steam power. This was the first great revolution in human history, perhaps the greatest revolution of all, when we conquered energy in the form of steam power. And then, around 1900, with the work of Thomas Edison, the work of physicists like James Clerk Maxwell, we discovered the electric force. With Maxwell's equations, we can now harness the power of magnetism, the power of dynamos, the power of generators, all from the mind of a physicist. That's the second great revolution in human history. The third great revolution in human history was when we physicists predicted the power of a transistor. The transistor changed modern society. Look on your desk. Look on your laptop. Look in your pocket. Look inside your body. Even today, people can have chips inside their body for medical reasons. We now have telecommunications beyond comprehension. And now, I give you the question for today. If the first revolution was steam power, second revolution was electricity and light, the third great revolution was the transistor, what is the fourth? What is the fourth great revolution that we're now experiencing? And then, what is the fifth? In other words, what is the destiny of civilization itself? That's today's talk. I say that the fourth great revolution is going to be physics at the molecular level, which means artificial intelligence, which I'll talk about today. Artificial intelligence, nanotechnology, and biotechnology. These are the revolutions of today. These are the revolutions which are affecting medicine, energy, our way of life. This is the revolution we are now entering today. But we physicists can see beyond this. What is beyond this revolution that is now changing human society? I say the fifth great revolution in human history is physics at the atomic level, which means, for example, fusion power. We're talking about the power of the sun on the earth. This is the greatest power source known in the universe. And at Livermore National Laboratories in California, also soon in Kardashev, France, we will have fusion power plants. Energy from the sun. This is how the sun lights up the morning sky. We will have the power of fusion in the coming decades. Next, quantum computers shown here. Realize that the future of digital computers is to wind up in a museum. Just like we see the abacus, just like we see the hand-crank calculators that our great-grandparents used to use. They're all in museums. Your laptop is next, to be replaced by something called quantum computers, which is one of the subjects of today's lecture. This is big. This is huge. All the nations of the world are trying to perfect this technology because there's a race to see who can create the first operational quantum computer. And then next, beyond that, we're going to unlock the secrets of the living brain. We're just now at the point where we can begin to see thoughts as they're being formulated in the human brain. Entrepreneurs like Elon Musk are betting that you can make money on this technology, being able to read the human mind. And already we can extract photographs. In my book, I showed you that when I went to Berkeley, where I got my PhD years ago, they can actually extract photographs right there from the human brain. This is amazing. Think about it for a moment. Thoughts of the human mind can now be photographed. So let's talk about the future now. What does this mean for your life? What does it mean for your job? What does it mean for your friendships? What does it mean for society itself? Well, the first impact is information will be everywhere and nowhere. You simply call for it. And on the internet already you see the beginnings of that technology. In the sciences, we'll be able to create works of scientific miracles by thinking about it. We'll be able to think the DNA molecule. We'll be able to manipulate chemistry. We'll be able to create new works of art, new works of science by simply thinking about it. And maybe you don't like those glasses. Maybe you don't like these clunky headsets that you have to put on. Maybe you don't like that. In the future, you will blink. You will blink and access the data of the entire planet Earth. All digital knowledge will be yours by blinking. When you meet somebody on the street, your contact lens will identify who they are. You'll know exactly who you are talking to, their background, all of this right there in front of you. And this could change human relations. Think of it. Let's say you're on a blind date. Let's say you're on a blind date, and your partner says that he's rich, he's powerful, he's famous. But your contact lens says, nope, he's a loser. No, he's paying child support for 4 women. No, stay away from this guy, okay? You'll know everything about who you're talking to by blinking. Think about this. You're looking for a job. You're at a cocktail party, and there's some very heavy hitters at that cocktail party, but you don't know who they are. In the future, you will know exactly who to suck up to at any cocktail party because you'll know who you are looking at. All of this because of the power of nanotechnology. And this is the car of the future. The car of the future, when you park the car, you simply talk to it. And you tell your car, park yourself. The car scans the internet, searches for any spot that's still available, takes off by itself, and parks itself. We're talking about robotic instruments, things that we take for granted, like automobiles, will be intelligent. You'll talk to it. You'll argue with it. You want to know the quickest path to a vacation spot? You think you know the best way, but your computer says, no, I know a better way. And so there you are arguing with your computer. And so we're talking about the fact that every aspect of our life will be digitalized. And this means that we may be able to break the sound barrier. Once upon a time, we had the Concorde. It was a supersonic airplane, but it crashed. And the problem was that it broke the sound barrier. You cannot break the sound barrier over a city because all the windows get shattered. And so what was the future of the supersonic jet craft? It's a museum piece, basically. In the future, we will be able to minimize the impact of the sonic boom. Think about this. Leaving New York, going to Beijing in just a few hours' time. This is going to change the nature of air travel, shortening it, because we'll be able to break the sound barrier without breaking windows. And so this is the future of transportation. But beyond airborne transportation, we're also talking about going into outer space. This is the future of space travel. It'll be commercialized for you and me. Let me explain. Take a look at logging, the history of logging and agriculture. In stage 1 of logging, you had trains that transported logs. Then people realized, now wait a minute, humans can also be on that train. And all of a sudden we created luxury liners like the Orient Express for rich people. So something that was used for logging was now used for rich people. Well, today, anybody, you and me, can get on a train. Rich or poor, you get on a train. That's stage 3. We are now entering the next stage of space travel. In stage 1, only United States and the former Soviet Union had the power to put humans into outer space. That's stage 1. Only the superpowers had access to outer space. Now, rich people, millionaires, can now go into outer space. One of my friends did it just a few months ago. And I asked them, how much does it cost? How much does it cost for a human without any kind of special training, no military service, but just an ordinary person? How much does it cost to go into outer space? Well, he was a little bit hesitant. But I said, $500,000? And he said, close. You can become an astronaut. That's stage 2. Stage 3 is mom and dad go into outer space. Outer space will go the same way as the railroads. From superpowers using this as a weapon of war to millionaires taking off into outer space until you and me go into the atmosphere. So this is the future of space travel. Space travel is going to be democratized. It'll be to the point where the average person may have access to outer space. And even beyond that, maybe you'll be able to vacation in outer space. The cost of space travel is dropping like a rock. Now, why is that? Think about it for a moment. What is the future of a rocket? You shoot a rocket into space, and it lands in the ocean. End of story. Is that rocket reusable? No. It's at the bottom of the ocean. Today, rockets are reusable. Elon Musk and others realize what a waste. All our rockets wind up in the bottom of the ocean. Why not retrieve them? Give them a second life, a third life, a fourth life, and that has revolutionized space travel. The cost of space travel has dropped in the same way that the cost of the railroads has also dropped. So this could be our future. And beyond that, we're going to go to Mars. Already the basic groundwork is being laid. In a few years, the first people will be able to go into outer space, go around the moon, and eventually on to Mars. So this is the next goal of the space program. Now, you may ask yourself another question. Why bother? Why bother to spend all this money to go to Mars? Well, I once asked Carl Sagan that question. Why bother to spend billions of dollars to go to a dead planet, Mars? And he said something that impressed me. He said, we need an insurance policy. Life only exists on the Earth. If something were to happen to the Earth, that's the end of the human race. We need an insurance policy, and that's the purpose of going to Mars. And now let's talk about energy for the future. As I said before, in California, at the Livermore National Laboratories, for the first time in history, they hit break even. They can now extract energy the way the sun lights up the universe. Fusion power, the power of hydrogen fusion. Next is Cardèche, France. In the next year or so, we're going to see the beginning of the European fusion plant. This could be the future of energy. Of course, it'll still take years to perfect the technology, but it's safe. Can it melt down? No. Does it create waste, nuclear waste? Well, yeah, a little bit, helium gas. But it does not blow up like a potential 3 Mile Island. We're not talking about fission power. Now, let me ask you another question. Does Mother Nature use fission? No. Where in the universe do we find fission? Only on the Earth. Only on the Earth do we see fission of uranium. Mother Nature uses hydrogen. Hydrogen, safe, clean, indestructible. Fusion is the future. And we have to realize that if things go wrong, this happened to the dinosaurs. It could also happen to us. Whenever I see this picture, I say to myself, what is that dinosaur thinking? And I say to myself, that dinosaur is probably saying to itself, "Aw, shit." There goes the age of the dinosaurs. That's what happened to them. And now, let's talk about your desk. What's on your desk? What's on your laptop? How will that affect your job? We're now going to talk about the digital revolution and the next revolution beyond that, the quantum revolution. And all of that will take place in your bedroom. So let's talk about this. First of all, a tape recorder simply takes sound, converts it into electric impulses, and records it. That's called the recorder. Now we have a recorder which has a little bit of intelligence. Intelligence enough to edit, cut up, resplice information. So that if you want to write a letter, instead of beating yourself about how to write a letter, you simply push a button. And the computer gives you sample letters, birthday cards, essays about congratulations on graduating from high school, anything. We're talking about a revolution in information, using artificial intelligence to splice together information in a way that conveys a message. These are called chatbots. And what does that mean? It means an increase in productivity. It means increase in content, access to knowledge. And in the future, all journalists, people who write, people who create copy, will use these chatbots because that'll accelerate the thinking process. Now, can the chatbot really think? Is it imaginative? Is it really alive? Some people think so, but I don't. It's a machine. It's a machine that takes what is already on the web, cuts it up, resplices it, and then it passes off as if you wrote it yourself. So in other words, chatbots are great. They've already changed the nature of literature. Newspapers are now written using chatbots. Perhaps the letters you write are done by a chatbot. So what's the downside? The downside of the chatbot is it does not understand the difference between right and wrong. Now think about that for a moment. Do you consciously lie when you write letters? No. You want to tell the truth. But a chatbot doesn't know that. A chatbot does not know the difference between right and wrong. It'll lie through its teeth. It takes what's on the internet, cuts it up, and resplices it. But what's on the internet? Garbage. There's plenty of garbage on the internet. And so these chatbots will also cut up garbage. And not only that, chatbots can impersonate. They can be engaged in criminal activity. They can put words in the image of a movie star and have it say anything you want in the tone of voice of that movie star. So there's a downside to this technology. This technology simply takes what's on the internet, cuts it up, and resplices it. But if there's junk on the internet, what does it do? It cuts up the junk, resplices the junk. And so, watch out. Now, I'm a professor. We professors sometimes assign term papers for our students. Every teacher now has to worry. The term paper that comes in, is it plagiarized? Chances are yes. So what do? You were a teacher. You assigned your students to write an essay. But the essays all look the same. Word for word. All the essays that come in look the same. What do? You get your chatbot to spot similarities between what comes in. In other words, you use fire to defeat fire. That's how you detect cheating. People will cheat. That's a given. But by analyzing the cheating, you can tell which one is true and which one is false. So use chatbots to defeat chatbots. And chatbots will also hallucinate. Now, we hallucinate. When we're overworked, we're oversaturated, we daydream. We hallucinate. We think of all sorts of crazy thoughts. So will a computer. How does that work? Let's say you want to write an essay about Mark Twain, famous American humorist, and you ask the chatbot, tell me what Mark Twain wrote last year. Simple question. Tell me what Mark Twain wrote last year. Well, Mark Twain didn't write anything last year because he died. So what does chatbot do? Makes it up. That's called hallucination. When a chatbot simply fabricates all sorts of nonsense. So what are the limitations of chatbots? Chatbots will eventually be asked to testify in courts of law. So far, the courts have not yet decided what to do about this, because chatbots will lie, but they'll also create beautiful prose, they'll create tremendous works of art, but they can also lie. So that's going to be tested in the courts. Is the testimony of a chatbot will be allowed in trials. And there are limits to free speech. You cannot allow people to yell fire in a crowded theater. People could die if you yell fire in a crowded theater. So there have to be restrictions on chatbots. And then the next question, the question that's allowing a lot of people to squirm in their seats, will a chatbot take my job? Listen carefully now, because this is going to have a direct impact on your life. Will a machine take your job? That's what we're going to answer today. First of all, let's talk about blue-collar work. Let's talk about repetitive blue-collar work. Those jobs are going to go out the window eventually. Jobs that are repetitive, jobs that you repeat the same motion over and over again, those jobs are doomed because eventually computers will be able to do those things. But what about semi-skilled blue-collar jobs, like sanitation workers, like plumbers, like gardeners? Those jobs cannot be replaced anytime soon. Let me repeat that again. Jobs that are blue-collar, that are non-repetitive, like carpentry, hammering a nail, picking up different pieces of garbage. Each task is different. Robots don't understand that. They don't know the difference between garbage and something real. So what happens? Those jobs will survive. Now, a high-level job may go out the window. If you were an accountant and you do the same thing over and over again, watch out. Your job could be next. But if you're a plumber, every piece of plumbing is different. No two leaks are the same. So it means that those jobs will survive. So believe it or not, gardeners, sanitation workers, carpenters, construction workers, those jobs will survive in the future because they are non-repetitive. And next, jobs that involve human interaction, like school teachers. You may say to yourself, well, school teachers are not so educated. They're going to go out the window, right? No. Because if you're a school teacher, you have to deal with hundreds of different kinds of problems that children have. Children's parents are divorced. They're yelling at each other. The kid cries all the time. The kid involves fist fights with bullies. He cries all the time. None of them can learn. Robots cannot handle that. Robots cannot handle human dysfunction. So those jobs will survive. Jobs that involve intense human interaction will survive. So, counselors, teachers, advisors, supervisors, these jobs involve human common sense, analyzing how humans behave, anticipating these things, counseling them, giving them real advice. Those jobs will survive because robots are clueless when it comes to human behavior. And jobs that require analysis. If you are an analyst analyzing the stock market, can a computer analyze the stock market? Well, yeah, to a degree. But if you want to understand human behavior, that's what you need to crack the stock market. And if you were a leader of a group in your company, you realize that you have to understand the strengths and weaknesses of everybody in your staff. Who talks too much? Who gossips too much? Who goofs off too much? Who's a leader? Who's thoughtful? All these things require human value judgments, none of which computers have. And now, let's talk about my conclusion. The next step beyond all of this is quantum computers. They were once considered to be science fiction, and now they exist. And the first question is, will it take your job? And the second question is, what can I use a quantum computer when faced with cancer, disease, starvation? This is a quantum computer. Actually, I lied to you. This is not a quantum computer. This is a quantum computer. This is what does all the dirty work. What is all this about? These are cooling pipes. Cooling pipes to bring down the temperature near absolute zero. So you see these pictures and you say, oh my God, look at that thing. It's cooling pipes you're looking at. The actual busy work is done by that little thing in the bottom. So what's all the fuss about? Why all the fuss about quantum computers? Well, first of all, there's a race. This is the Chinese model. The Chinese are betting that this thing here will use optical light to compute. Now, why bother? What travels faster, electricity or light? Let me ask that again. What travels faster, electricity or light? The answer is light. The Chinese are betting on light, not electricity. This is an optical quantum computer. Look at all those mirrors. See these mirrors? And you may say to yourself, this is faster on certain problems than any known digital computer. So what's the catch? There's always a catch someplace, right? Otherwise, the Chinese would have taken over the world. Why isn't the Chinese quantum computers dominating everybody? And the answer is, if you want to change this computer to solve a different problem, you have to rearrange all the mirrors because every arrangement of mirrors is suited for one problem. Okay, now your digital computer on your laptop right now is versatile. It can do many things simultaneously. Quantum computers cannot. They answer one question at a time. And that's the reason why, even though the Chinese quantum computer does exist, it's one of the fastest on the planet Earth, in fact, it can only do one problem at a time. So in other words, laser beams, yes, that is a way to compute. That's what the Chinese are betting on. But in America, we're betting on silicon. Silicon worked quite well for the digital era, and the hope is that they will also work in the quantum era at all. Who are the leaders? The leaders are IBM, Microsoft, and a few others like Honeywell. These are some of the leaders in the race to perfect the next generation of computers. And what's at stake? Everything. Your job, your way of life, what you can do with it, all of that is a byproduct of this race that's being conducted right now. And who's monitoring that race? The CIA. So why? What's all the fuss about? I mean, why is everyone talking about these things now? Well, digital is based on two things, up and down, up and down. Think of an atom. A spinning atom can spin this way, or it can spin this way. This is called digital, where you compute on zeros and one, zeros and one, zeros and one. So why bother? Because the world economy, the wealth of nations, depends on zeros and ones, zeros and ones. What does your bank account look like to a computer? Zeros and ones, zeros and ones. What is your health report that your doctor writes up? What does that look like? Zeros and ones, zeros and ones. Now let me ask you another question. Where in the universe do we find zeros and ones, zeros and ones? The only place we know of in the universe that uses this backward technology is called the planet Earth. Mother Nature does not use digital. If Mother Nature is not digital, then what is Mother Nature? And the answer is quantum. Mother Nature is a quantum computer. So instead of just up and down, in a magnetic field, atoms can spin in any direction whatsoever. Now, what packs more information? Think about it. This is the key question. If you get this, you're way ahead of everybody. What packs more information? Up and down, or any angle whatsoever? What packs more information? That's the key. That's the trillion-dollar question. The answer is this. The fact that atoms can now all rotate in any direction that you want. Now, what can you do with this? Let's put a mouse in a maze. And the mouse has to travel through the maze. How does it do it? A digital computer, it says the mouse can be either moving in left or right. Left or right. So every time the mouse hits a juncture, the computer says left, right, right, left. How many paths are there? Thousands of paths, each based on turn right, turn left, turn right to left. And that's called a maze. This is called a digital computer. You got that? Now replace this with a quantum computer. How does a quantum computer solve this problem? It maps all paths simultaneously. Let me repeat that again. It maps all paths simultaneously to extract out the one that is shortest. That is the key to this whole puzzle. This is the trillion-dollar question. The economy of the nations of the earth depend upon this. So how does that work? Well, if I take a gun and I shoot a gun through a hole, the bullet only goes through one hole at a time. If I put two holes, the gun can go to the left or go to the right. One bullet at a time. You got that? In the quantum world, the electron is a wave. When the wave goes through these two holes, what does the wave do? It goes through both holes simultaneously, right? Now that violates common sense. Common sense says you can't do that. Waves can. So is the electron a wave or a particle? And the answer is it is both. It is a dot particle whose position is given by a wave. In other words, your mother told you when you were a child, you cannot be two places at the same time. Remember that? People told you, you cannot be two places at the same time. Well, we lied to you. At the quantum level, you can be in many, many places at the same time. And that's called the quantum world. Welcome to the bizarro world of the quantum. You can be in two places at the same time. And what are the consequences of that? Television, radio, microwaves, electricity, all the things that you know and love in your house depend upon this fact. And atoms can also be entangled. They can talk to each other. Ordinary atoms cannot. And who's worried about this? The CIA. The CIA realizes that in the future, a rogue nation will be able to break into any code whatsoever. There's a race to see if you can figure out a way. In fact, if you want to become a billionaire, figure out a way to stop this revolution. And the revolution, of course, has practical implications. I'll wind up on this note. We're talking about agriculture. We're talking about medicine. We're talking about Alzheimer's disease. These are all byproducts of molecules gone berserk. This is the realm of the quantum. Quantum computers may eventually solve problems like Alzheimer's disease. Not only that, but cancer. Cancer is when molecules go crazy inside a genome. How do we cure cancer today? Well, you can have X-rays, you can zap it, you can cut it up, you can poison it. That's crude. That is so crude, the way we attack cancer. In the future, we'll attack cancer at the molecular level. And one way to do it is to analyze our byproducts. You realize that today, for COVID-19, we analyze sewage. By analyzing sewage, we know exactly which areas are contaminated with a certain version of COVID-19. We'll do that with cancer as well. And so, the aging process. Why do we have to die? Is it possible to become immortal? Well, yes. There are certain animals that are immortal. The hydra, found in ponds. You cut off a leg, it regenerates a leg. It regenerates itself. It is immortal. And once we find the secret of the aging process, what is aging? Aging is entropy, the buildup of errors inside the reproduction of a cell. Quantum computers will be able to isolate the breaks and the mistakes at the genetic, atomic level that causes us to die. So in other words, we're talking about a new world. Forget the digital world of the past. We're entering a new world, the world of Mother Nature. Mother Nature is a quantum computer. Mother Nature is not digital. Mother Nature works with cells, molecules. Think of your car. Where is the information of a car stored? Where does wear and tear take place in a car? Think about it for a moment. If I have a car, why do cars age? It's the engine. When the engine starts to accumulate errors, that causes the car to malfunction. Now take a human. Where does aging take place in a human? In the mitochondria. If we can solve the error buildup in a mitochondria, we might be able to live forever. And now let me end up on one short story. Let me end up on what happened to Albert Einstein one day. Albert Einstein, when he was an old man, used to give the same talk over and over again, and he got very tired. One day his chauffeur came up to him, and the chauffeur said, "Professor, I'm really a part-time actor, not just a driver. I've heard your speech so many times, I've memorized it. So why don't we switch places? I will put on a mustache, I will put on a wig, I will be the great Einstein, and you can put on my jacket and be my chauffeur." Well, Einstein loved the joke, so they switched places. Well, this went along famously until one day, a mathematician in the back asked a very difficult question. And Einstein thought, oh, the game is up. But then the chauffeur said, that question is so elementary that even my chauffeur here can answer it for you. Thank you very much. You've been a great audience. Thank you.
Thank you very much. Muchísimas gracias al profesor Michio Kaku.